everyone. This series of videos is going to try to walk us through page 20 in your packet, which is all about solving trig equations. You may find that just by looking at the problems, or maybe just looking at the problems and the answer key, is enough to help you figure this all out on your own. So don't feel obligated to watch these videos, especially if you feel like you already get this and you can complete the problems without any guidance. The videos are just meant to help anybody who needs a little bit more specificity, or anybody who benefits from hearing or seeing a couple of examples worked out before they try on their own, but these are not mandatory in any way. So even if you want to watch just a couple of minutes, just enough to get the hang of things, you are certainly welcome to pause the video or stop it altogether, switch gears to independent work, and finish as many problems as you can on your own. If you feel like you need more examples than just the ones that I'm doing in the videos, you can always email me and I'll be glad to help you out. My email address has been posted on the website. It's also on Google Classroom. And if you got an email from me yesterday, I included it in that email as well. So lots of different options if you need help, especially if any of the examples that I'm doing here don't make sense, or if you just feel like it's not quite clear and you would benefit from having a little bit more guidance. Now, the first thing that you'll want to do if you're opened up to page 20 in your packet is to make sure that you have a unit circle to use for reference somewhere. I, for example, am just reusing somebody's quiz, so if you recognize your own handwriting, congratulations, you passed the quiz. But I like to have a physical copy of the unit circle near me for reference, and I may suggest you do the same. If it doesn't matter to you, or if you want to just take a screenshot of one that you already have, or a picture of your old quiz, especially if you don't really want to have the piece of paper out, do anything that helps. But I do recommend having a circle to look at for reference, because most of these questions, like everything else in the packet, are going to be based on the circle itself. So we're going to start with a couple of examples in question number 1, and you'll see that I have some little pink dots highlighted. Those are the questions that are basically the ones I would call essential, the ones that you would actually kind of need to know how to do. There are a few questions like letters G, H, and I that are a bit more challenging, so we're not really going to worry about doing those examples together, although the answer keys for those are available, and if you're willing to challenge yourself, I would definitely recommend trying them. Those, for example, are questions that I would expect if you're going on to honors math analysis that you would be able to tackle. So I'm going to focus in this first video on just the examples for question number 1, and we'll kind of do what we do in class. I'll do a couple of examples, and then I'll give you some time to work independently on the remaining examples in that section using the ones that we did together as a bit of a guide. In a separate video, you'll see some information about numbers 2, 3, and 4, and another separate video for numbers 5, A, and B. So if you go back and notice on YouTube there's a playlist, you are welcome to just kind of skip ahead to other videos or do the videos out of order, whatever makes sense to you. We'll start though in this video together with number 1, letter A. So in number 1, letter A, the goal is to solve for theta, which is kind of a fancy way of saying figure out where on the circle we must have been for this equation to be true. The problem is that this equation doesn't really look like a traditional equation. It doesn't look like the unit circle problems we're used to doing, so a little bit of cleaning up is necessary. As you probably know, when I say clean up, I really just refer to moving things around or getting cos by itself so that it looks more familiar. Let your algebra instincts be your guide here, because we've spent all year practicing for stuff just like this, where even if we don't necessarily know exactly what to do to solve, we can probably have a good gut instinct that we would do some of the things that we would do with other equations, like x squared type equations, or more complicated things from other chapters. For example, if your instinct was just kind of telling you, hey, move this -1, that's a good instinct. Generally speaking, we want to get that cos by itself, so moving the -1 is a good first step. If I add 1 to both sides, then I'll still have 6 cos theta, but now I'll be equal to, and then I can simplify 2 plus 1 is 3. So that's a good start. Now I definitely have less complicated stuff near the cos, and that's certainly positive, but let's see if we can keep going. The other thing that's kind of near cos that I'm seeing that just seems strange is that 6. We don't normally have a number in front of cos. Since 6 is multiplying the cos, instinctively it makes sense to divide it to the other side in order to get the cos by itself. So now that the 6's cancel, I have cos theta by itself, which at least looks like a somewhat normal problem now. And then I have 3 over 6, which is definitely not a familiar number. We haven't seen too many unit circle problems with 3 over 6. But if I reduce 3 over 6, I get 1/2. And now all of a sudden that looks familiar. 1/2 is a familiar number for us on our unit circle because there are lots of places on the circle that have measurements with the exact value or answer of 1/2. So this is basically a backwards thinking kind of question now. Cos means we were measuring the horizontals of our circle, and the answer came out to be 1/2. So the question is, where could we have been on the circle where we were measuring horizontally and getting an answer of 1/2, the short positive answer? So if I look at my circle now, I'm automatically kind of thinking about that number 1/2. That's the shortest distance. So since I'm thinking horizontally, I know that the short distances are the ones kind of closest to the y-axis. And since it's positive 1/2, I know that it must have been measuring to the right, because if I start in the center of the circle, all the things to the right are positive horizontals. So the two numbers that are jumping out to me here are up here at 60 degrees and down here at 300 degrees, because both of those are short horizontal measurements in their quadrant. They're both definitely positive, so I know that those two are the possible places that this question could have been referring to. Now, if you look at the answer space, it says radians, which specifies that when I state my answer, I want to state the coordinates, or not the coordinates, but the angle of those parts of the circle in a radian measure. So 60 degrees is really pi over 3. And the other spot I was looking at is 5 pi over 3. So those are the two answers that I'm going to write, pi over 3 and 5 pi over 3. Most of the questions that we're going to do here are going to have two answers because it doesn't really specify what quadrant we're supposed to look in. And since it's possible that there's more than one quadrant that could have a cosine that is positive 1/2, we just write both. And that should be the rule of thumb for most of these questions. Now, virtually every other question in this section, number 1, is kind of the same thing. Clean up the equation so that the part with the trigonometry, the sine or the cos, is by itself, and then hopefully you'll have a familiar looking number on the other side, a number that should resemble an actual spot on the unit circle that we recognize. We'll do one more just to kind of make sure we get the hang of it, and then I'll have you try a few on your own. The question that I'm going to skip to for a second is question letter E. Now, the reason why I'm going for one like that is just because it's a little bit different. If you look at it, the first thing you may want to do is ask yourself, okay, if I'm going to have to look for a familiar unit circle value, where can I pick up on some context clues? For example, I might ask myself, where do I usually see root 2 in these problems? Usually when we talk about root 2, it's part of a measurement, root 2 over 2. So that's kind of giving me a hint. This must be part of a root 2 over 2. And I must need to kind of move all this other stuff around so that I can force it to look like there's a root 2 over 2 kind of hiding in here somewhere. So let's think about the algebra. The first thing you might have noticed is that there is a cos on both sides. And if cos is kind of like a variable, then it kind of makes sense to group them together, just like we would normally get x's together if we were solving for x. So my instinct here, even though it seems strange, is to move this negative cos over to the left-hand side to join the other one, kind of like combining like terms. Since I do have to move across the equal sign, or move the cos to the left-hand side to the opposite, then I have to do the opposite of minus cos, which is going to be plus cos on both sides. That's just basic rules of algebra, but hopefully familiar. If I cancel on the right-hand side, that's good, because now I just have this square root 2 on its own. On the left-hand side, I do have something peculiar, though, cos plus cos. If you think about these things logically, though, cos plus cos would be 2 cos. We're basically just adding their coefficients, and then equals to the square root 2 that was already there. Now this I can kind of tell is starting to shape up a little bit, because now I can see that 2 in front of the coast, kind of like in the previous example we did, which is probably giving us a hint that if we clean it up by dividing the 2 to both sides, then all of a sudden the problem is going to take shape. I have coast by itself, which is what I wanted, and then I have root 2 over 2, which is that familiar number I was referring to earlier. We've seen root 2 over 2 before. So now that I'm thinking about my circle again, I'm thinking about horizontal spaces where the length is positive and medium. So going back to my circle again, I'm thinking about the right-hand side of the circle again, because that's where all the cosine or horizontal values are positive. And I'm thinking about the medium length this time. So this time the space is at pi over 4 and 7 pi over 4 are jumping out to me, because those are the medium lengths in their quadrants. Again, we don't know which quadrant we're supposed to be in, so we have to write both as our answer. It looks like pi over 4 is one possibility and 7 pi over 4 is the other possibility. Again, pay attention to the answer spaces because it will dictate what kind of units you use for your answer. This one, again, says specifically radians. So now that you've seen a couple of examples, I do think you'll be able to go through all of the problems in number 1 from A through F with these as a bit of a guide. If you have any questions, you can always look back at the answer keys. So again, might want to consider having the answer keys open in a separate tab or a screenshot of the answer key that you can quickly refer to. Maybe even if you have a printer, print the answer key. So that way you can refer to it as you work. Sometimes it does get helpful to see the answer because sometimes you can work backwards and figure out the logic behind a question just by seeing the answer. In the next video, we're going to talk about numbers 2, 3, and 4. So my suggestion is, at this point, try to finish numbers 1A through F and check your answers. And if needed, tune into the next video to look at numbers 2 through 4. As a disclaimer, if you feel like you understand number 1, you might not need examples for 2, 3, and 4. So feel free to give them a try, especially if you've got a bit of momentum.